We're now going to look at the converse of Pythagoras. Converse of Pythagoras is basically a way to determine whether a triangle is right angled or not. We already know that Pythagoras' theorem can only be used in right angled triangles, and therefore if a triangle is right angled, then Pythagoras' theorem should hold true. So conversely, if we can show that Pythagoras' theorem holds true, then we can state that the triangle must be right angled. In these two examples, we'll be asked to show whether or not the triangles are right angled. Now, we should know where the right angle will be if it is indeed a right angle. It should be opposite the longest side. So what we're really looking to do in, for instance, the first example, we would expect if this triangle is right angled for the right angle to be here, opposite the longest side. Remember, the right angle would always be opposite the hypotenuse. So to do this, what we can do is we can just start by labelling the sides. We'll call them A, B and C. Usually I'd make the hypotenuse A, or the longest side A. So start off by working that out on its own. So A squared equals 25 squared, which comes to 625. Now the other side of Pythagoras' theorem, we normally have A squared is equal to B squared plus C squared. So we've done one side of that formula. So we'll look at the next side, B squared plus C squared separately. That comes to 15 squared plus 20 squared. And again, I can type this in my calculator quickly and I get 625. What I can then do is make a statement based on that. So I've shown there that A squared is the same as B squared plus C squared. So we can make a statement that 25 squared is equal to 15 squared plus 20 squared. So by converse of Pythagoras, the triangle is right angled. Okay, so we want to learn this statement off by heart. And the statement and the working should probably look exactly like this. In the second example here, again, we start off, we can look at labelling the sides. The right angle, if it is a right angled triangle, would it be here, opposite the 13, opposite the longest side? So we'll start off, we'll call the 13A, and we'll call the other two sides B and C. And again, just repeat the process. So we'll start off with A squared equals 13 squared, which is 169, and B squared plus C squared separately is equal to 12 squared plus 6 squared, which comes to 180. Now in this case, what we can see is A squared is 169, and the other side of Pythagoras' theorem, B squared plus C squared, is 180. These two things aren't equal to each other. So we're going to use the not equal to symbol. We're going to say that 13 squared is not equal to, and again look there, we're using the not equal to symbol, 12 squared plus 6 squared, and therefore by converse of Pythagoras, the triangle is not right angled. These questions are ones where the communication and the statement you make have to be quite precise. So making sure that we do it exactly the way it's laid out here, with the two separate parts, so A squared totally separate to B squared plus C squared, making sure this statement here is written in full and you can learn it off by heart. It's really worthwhile in this one trying to find an SQA question and looking at the marking scheme to see what's acceptable. So a recent marking scheme ideally, and look for the notes at the bottom. What's really important is we don't start off by making the two parts equal to each other. For instance, in part B, it would be incorrect to start off with substituting all the numbers into Pythagoras' theorem and starting off with something like 13 squared equals 6 squared plus 12 squared. Remember, the idea of this question is to find out if the two sides are equal or not. We can't do that if we start off by stating that they are equal. So this part in red would be incorrect and would cost you marks in the exam.